Good night, good night, good night. Good night, Jada. Can you hear me? See Lev, Musically X, Akelia, good night. Peart, good night, good night, good night. Hi Mills, how you doing? Abby. All right, Kelly's, I'm seeing you. Alton, good to have you. Good night, everyone. Hope that we are all doing well. Let's see who is here. All right, hang on a sec. Let's get all set up. All right, great. So, see Irving just joining. Night, Irving. All right, cool. Let's get the show on the road with those who we have here. Let's go. So, in our last episode, we were completing this puzzle. Hope you guys were here then. If not, you could just go back to our previous episode, and we have some clues left to use. Some of them were not things that we would have done regularly. For example, this one, correspondence. This one here, correspondence. A lot of people said the answer then, but there's something I wanted to show you guys with regards to correspondence, and we weren't able to do that one just then. Let's go here. Let's see if I can pull this out the way. Correspondence, let's look for the meaning. A close similarity or connection or equivalence, okay? So let's look at a one-to-one correspondence. Here, for example, we have a ladybug, one ladybug to a leaf. There's a connection, okay? So a one-to-one connection there. We can see that like in sets and other areas of mathematics as well, where they have one-to-one correspondence. Okay, hope that one helps with regards to that. Let's see. Let's see if we can get our grid back up. Hang on. Let's pull this back. All right, cool. So we have our grid here and our puzzle, and we were completing. Let's go here. This one. Several persons said diamond. Diamond. Let's go Let's make this all caps. Diamond. And this was supposed to be a quadrilateral, okay? Diamond, diamond, diamond. All right, so this is 23 across. Let's go to the clue. 23 across a quadrilateral and diamond. A lot of people are going to say, how a diamond? All right, so let's go. Let's pull this a little. And let's see if we can show this diamond. Now, in baseball, for example, in baseball, in the game baseball, they use a diamond. Okay, so here's a baseball diamond. Okay, this is what it looks like. And if you can see here, we can see one side, 2, 3, and 4. Okay, so something with 4 sides, we all know that would be a quadrilateral. Okay, so diamond would fit there as well. Let's go back. So we have our diamond here, 23 down, a type of roof, and our answer here should be dome. Okay, dome. Let's look at what a dome looks like. So Google dome. Dome roof houses look something like this. We see the dome, dome, dome here, dome. So that's pretty much that. Our answer there being dome. All right, I think we have one left, and yeah, this one is supposed to be cycle. Okay, cycle. and that will complete the puzzle, and we have all of those in. So for number 1 refers to the mean, mode, or median, right? Average. Let's go here. 3 across. What are numbers ending with 1, 3, 5, 7, or 9? What type of numbers are those? All of those would be odd numbers. Let me just check to make sure that we're all hearing. Tess, are you hearing me?
Yes, sir.
All right, so odd numbers there. Let me get another one. Let's see. We have here opposite of columns. We know that would be rows. A special shape or type of roof. We know that one was dome. Okay. Let's see if we can find a few more. Something that's not open. That would be like a closed path. And 3 and 5 are factors of 15, equal in some way, correspondence. 8 is the third power of 2. A number with only 2 factors. Prime, the difference between the highest and lowest values in a set of numbers. That would be the range. To simplify, we could say cancel, or, well, it has to be cancel to fit this one, but we could also use terms like reduce and so on. Okay, so that was our puzzle then. Now we started looking at this. We started looking at the strands of math and the different areas. So we know we have sets, number values, fraction ideas, estimation and mental calculations, multiplication and division of whole numbers up to 4 digits, decimals, right? Those are grade 4 things, units of measures, computing units, computing length and area, estimating and comparing with what? With measures, okay? Those strands now for geometry, relations between lines and angles, lines of symmetry, similarities and differences with regards to shapes. And we know algebra, as usual, we're using variables, okay? So we need to bear all of those topics in mind. And when we're reviewing our math, we don't only review those areas that are, nice, not the ones that we like doing. For stats and probability, you know that we want to focus on collecting and organizing, interpreting and displaying information, the mean, sampling and population, and the outcome of an event. All right, let's get to our questions now and see how we can answer these. Let's go. Tess, let's see.
Yes, sir.
Which is the odd word out?
Okay, sir. My options are A, mean, B, mode, C, multiple, and D, median.
Mm-hmm.
Sir, my answer would be C, multiple,
And why would you choose C multiple?
because the three M's, mean, median, and mode, are all a part of the same topic.
Mm-hmm. And what topic would that be?
Um, the three M's.
Statistics.
Oh,
Okay, statistics. But the multiple is not necessarily something that we would find in stat just like that. Okay. All right. Let's go with number 2. Number 2 is interesting. It says here, 9 times a variable, okay, x, and five times another variable y result in 62. Okay, what pair of values of x and y will satisfy the expression? All right, panelists. I see Tess and Brianna. First of all, let's get this information down on paper. Let me see if I can pull this camera up and get that here. So 9 times a variable, and that would be x plus 5 times another variable y, and all of these should be equal to 62. Now we need to solve for what is x and what is y, so that when we're done, we'll get 62. How do we go about this? Help me with this one. Test, Brianna, what do I do?
-5.
Any thoughts? Where do we start?
Sir,
Test.
I would minus 5 from 5y and the 5 from 62.
Okay. All right. And when you do that, what would happen next? Because you'd be left with pure x and pure y. Where do you go after that? All right, let's think about it like this. Test anything before I start trying to wrap my head around this one?
No, sir.
All right, let's go with this. 9 times 1, that would be what? 9. 9 times 2, this is 18. 9 times 3, what would that be?
27, sir.
27. 9 times 4, this would be
36.
36. 9 times 5, this would be
45.
45. 9 times 6, that would be
54.
54. 9 times 7, this would be
63.
63. I'm going to stop here because I have all factors of 9 that are now just above 63. Let me go with 5. All right, so 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 fives, 5 sixes, 5 sevens, 5 times 8, 5 times 9, 5 times 10, 5 times 11, 5 times 12, 5 times 13. Let's go with this. 5, 10, 15, 20, 25, 30, 35. Let's go 40. No, this is 40. 45. Let's go 50. 5 11s, 55. 5 12s, 60. I have to take one more. This would be 65. I can stop there. All right, let's go with this. I need some factor by 9 that when I add it to 5 times this one, I get 62. Could I add 9 times 1 and 5 times 1? Would that work, guys?
No, sir.
That wouldn't work. Could I take 9 twos 18? 18 and 5 would make what?
23, sir.
Would be less. So let's take 27. 27 and 5. That would not make 62. 27 and 10. That's 30 something. 27. And if we continue this process, we're going to see that we get 27 and 35. Okay. 27 and 35. When we add these two together, we're going to say 7 and 5. This would be 12. I write 2, carry 1. And I say 3 and 2 would make 5, and 1 would make 6. Now, it's going to take more time than we have here, because what I had to do, test this one with these, then go ahead, test it, and continue until I found out that it was 27 and 35. Now, if this is the case, what does it mean that we're going to multiply 9 by? 9 would be multiplied by what? Here?
3, sir. So x would
3.
equal 3.
Okay, so x is equal to 3, and y would be equal to what?
7.
7. All right. So this one is a long one based on how it is here, but I'm going through in this way so that you can clearly see that 9 times the 3, okay? So 9 times or 3 here, plus 5 times or 7. If we were to put these in brackets, we're supposed to get 62, okay? And 9 times or 3, this would give us 27 on this side, plus 35 here. And when we add those, we're going to get our 62. Okay? Now, what is the big idea for this particular question? What topic does this fall under?
Algebra, sir.
Very good. So this is algebra. All right. So when we're looking at algebra, there are certain things that come out. We have what we call constants and variables and all of those things that are important to note. Okay? All right, hang on a second and let me get this back. All right, let's go. Give me a sec. All right, good. So variable here, and we were simply being asked to say what x would be and what y would be in this situation to make this side equal to this side. Okay, so remember, when we have an equation, we have things that are on the left-hand side and we have things that are on the right-hand side. And the aim, once we have an equation, once there's an equal sign, okay, the aim would be to find out what we're going to do with this to make it equal to this or vice versa. Okay, again, big idea here, algebra. Remember, constant variables, making them equal so that it can be balanced. Okay, got that, guys? All right,
Yes, sir.
let's go back to our screen. And we have another. All right, cool. So next question says, imagine a flag with 3 vertical stripes, 1 red, 1 white, and 1 blue. How many different flags can you imagine without repeating the color? All right, any thoughts on that one?
Yes, sir.
Tell me.
So the colors of the stripes are red, white, and blue.
Mm-hmm.
So we could have red, blue, and white.
Mm-hmm.
And we could also have red, white, and blue.
Mm-hmm.
Blue, red, and white.
Mm-hmm.
Blue, white, and red.
Yes.
White, red, and blue. and white, blue, and red.
How many total combinations there?
6, sir.
6 combinations. Let's see if we can get this. So I'll start with the combination that they gave us. We have one combination with red. Do I have, no, I can't write. Can't write with white. So we have red, white, and blue. And this is one possible combination. Let me see. Can I put this side by side so you can see this? Probably this is a little bit better for you guys to see. Okay. So red, white, and blue. That was one. Let's start with the red again. Another combination with red could be red, blue, and white. Okay. Slightly different. Okay. Then we could start now with white. Okay. So let's go white. Then we could get white, red, and blue. Okay. Blue. Then starting with white again. Okay. We could mix it up now and say white, then blue, then red. Okay. Then we could go to blue. Okay. If we had blue, we could go blue, red, and then white. Okay. And one more, we could have blue again, but this time white, then red. So I'm seeing here 1, 2, 3, 4, 5, 6 possible ways of using these. So we use our reds first, and then we look at the combination with starting with red. Then I went to white, looking at combinations with white. Then I went with blue. So I used all of those at the top and then matched the others afterwards. Okay. All right. All right, Nelson, that's, let me just switch back now. Let's go here. All right. I hope that's better for you, Nelson. So we have done 1, 2, and 3. Let's go to 4. Now this one is interesting. Imagine some colored blocks are laid out in a row. 3 red, 2 blue, 3 red, 2 blue, and so on. How many blocks will be in the 9th position? Panelists, that one is yours. What do we know? What do we know?
Sir, we know that the pattern is 3 red and then 3 blue.
All right.
2 blue.
All right. Hang on a second. Let me see if I can put this. Let's switch this and get this side by side. Let's go here. Let's get a pattern going. So you said that it was 3 red. 1, 2, 3, and then 2 blue. 1, 2. And if this is the first instance of that, then we need second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay. No. No, I'm wrong. Hang on. So this is the second, third, fourth, fifth, sixth, seventh, eighth, 9. All right, cool. We have one too many. All right, let's go with this. So what would come next based on this?
So in the 3rd position, we would have 3 red.
So 3 red, then
2 blue.
2 blue, then
and then 3 red.
3 red again, then
2 blue,
blue, then 3 red, then 2 blue, then 3 red. So they asked us for the 9th position. So what would come in the 9th position?
3 red blocks, sir.
3 red blocks. Okay, 3 red blocks. So here, I hope that you guys are able to see this. Is it being blocked by anything? Tess?
No, sir, I can see.
Okay, you can see clearly. All right, cool. Maybe it's just my setup on this side. Okay, mine. All right, cool. So first setup, we notice that the pattern is 3, then 2, then 3, then 2. And in the 9th place, we'd have 3 red blocks being shown. All right, so that's just one part of this. If we go to question 5, we get another part to this. Question 5 says, imagine some colored blocks are laid in the row, into a row, laid out in a row. 3 red, 2 blue, 3 red, 2 blue, and so on. If there are 65 blocks, how many would be red? How can we solve this one?
May I try, sir?
Sure, tell me. Go ahead.
We could do it in a ratio.
Ratio. I like to hear that. Go ahead. Tell me what would I need to do?
Yes, sir. So for every 3 red blocks, we have 2 blue blocks. So our first ratio would be 3 to 2.
Hang on, let me get this on paper. So you're saying our ratio would be 3 to 2.
Yes, sir.
And the 3 would be for red blocks, and the 2 would be for blue. All right. So 3 to 2. Then what?
6 to 4.
6 to 4. Oh, I see what you're doing. All right. So you say 6 to 4. Okay.
Yes, sir. And then 9 to 6.
9 to 6. All right. Let's go.
And then 12 to 8.
12 to 8.
And then 14 to 10.
14 to 10. Let's see where this goes.
Wait, sir, not 14, 15.
Okay, because you're putting on 3 more.
Yes, sir.
So you have 15 to 10. All right.
Yes, sir. And then 18 to 12.
18 to 12.
And then 21 to 14.
21 to 14. How many would you have already?
Sir, that would be 35.
35. Okay. Then
24 to 16.
24 to 16.
And then 27 to 18.
27 to 18.
30 to 20.
30 to 20. That means that we would have 50 at this point. Let me go here. Then if we are continuing, what would we say next?
So we would say 33 and 22.
22. And that would make what? Total of what?
55.
55. We're not there yet because we're looking for 65. All right, let's go. 30 what?
36 to 24.
36 to 24. Okay.
Yes, and then we would have 38 and 26.
38 to 26. How many do we have now?
64.
38 to 26. Let's go 38. Let's go 26. And this is 14. Carry 1. We have 64. All right. That's interesting there. No, this is not 38. Because if we were at 30,
39, sir.
if we were at 30, right, if we were at 33 and then we went to 36, then this should be 39. Okay, so this is going to be 39. This did not sit right. Let's go 39, and then this would make 5, because we're looking for 65, not 64.
Yes, sir.
Okay,
So that would make the 65.
39. That's an interesting way of looking at it. In fact, I didn't look at it like this. You
Sir,
want me to? Yes. Go ahead, Brianna.
I have an easier way that I did.
Sure. But does this way work?
Yes,
Does,
sir.
okay, cool. So, all right. I never looked at it that way either. Tell me the other way you looked at it.
Yes, sir. So the ratio is 3 to 2. So I added the two ratios, which is
3 to 2.
5 and the
You added, so you add the terms in the ratio, and you would have gotten what?
5.
Cool. All right. Good. Then what?
The 3 is the bigger one, so I will put 3 over 5.
Okay. So
And
this
then
is
times 2.
so the
Yes.
red
And then
here 3/5.
and then I multiply it by 65.
Good. Of the total 65, let's say 5 into 65, 5 into itself one time, 5 into the 6, 1 remainder 1, 5 into, or 15 there would go 3 times, so that means 5 could go into itself one time, and 5 into 65 13 whole times. Now we don't have anything else left, so what do I need to do?
So if I multiply the 3 by 13, which is
Numerator
39.
by numerator, and we'll get 39 all over, 1 by 1. Any number divided by 1 remains the same, so this would be 39. So in terms of the red blocks, I would have 39 red blocks out of the total 65. But just to make sure, it would be good to what? To check. Okay, so I'll continue now working with the 2. So what would I need to do with that 2?
You put the 2 over the 5 now.
All right, so this would be 2/5 of the 65, telling
65.
me the blue blocks. Tess, are you seeing this one? Tess?
Yes, sir. I did a similar way as well, except not in the fraction form.
All right, cool. Let's go again. We know that 5 into itself one time, right, Bree? And 5 into 65, 13. And then numerator 2 times or 13 now would give us what?
26.
26. All right. So if this is 26 and we know 39 plus or 26, 9 and 6 would give us 15. Write 5 and carry 1. 1 and or 3 would be 4. 4 and or 2 would be 6. Okay, Bree, well done with this one.
Yes.
So love it. This way is a lot faster than listing out or ratios here and going step by step and going through. But it's important for us to see that, hey, we could do it this way. We'll get to our answer eventually. Okay, simple, just checking, going on and on until we get to our 39 and 26, giving us the 65. Or we could add the terms in the ratio, the 3 and the 2, getting a total number of shares being 5. Therefore, the red blocks would be 3/5 of the total, and the blue blocks being what? 2/5. Okay, then 3/5 of the 65 would give us 39 in all, and 2/5 of the same total would give us 26. When we add those two things, we would get our 65. Brilliant. Is there any other way that this could be done? Let us say that we have a student who is not so comfortable with this and not so comfortable with this. How else could we help that student? Any other way you're thinking of? Anybody?
Sir, I have a very similar way to a
Yes.
whole. We are not doing except not in the fraction form.
Let me show you this. 65, yes, sir. Okay, so let's look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, and then 61, 62, 63, 64, 65. Okay. So 65, and what I did, I just wrote them out based on how they appear. This would be red, this would be blue, and so on. So let's go labeling these. So this is red, 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 red here, red here, red, red, red. And all the others are blue. Blue, 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 and so on. Blue here, blue here, blue here, blue, 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 blue. All right. So if we have a total of 65, how many red groups should we have? Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? Now, 13 groups multiplied by 3, how many do I get?
39, sir.
39. Okay, then how many blue groups do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 groups, and this was for the red. So we have 13 blue groups with 2 each. Let's multiply those. What do I get now?
26.
26. So if I add my 39 red and my 26 blue, I will get what? 65. Now, gentle folks, make we look on this again. First, when Tess approached this, she looked at the ratio and she kept adding to the ratio until she got to 39 and 26. That's one way of doing it. Totally acceptable. You get the answer. Okay, hang on. That was just adding and continuing. This way, using the ratio here, excellent work. This way, nice and fast. Some people still can't see it like that. However, if we take it to the simplest form and just keep the pattern going, 3, then 2, then 3, then 2, then 3, and we continue counting this or setting them out like this until we get to 65. When I check all the reds, I know I have 13 of them, and in each group, I have 3, right? And if I continue and check them out, I will have 39 red, and I'll have 26 blue, and that will give me the 65 that I was looking for. So guys, 1, 2, 3 possible ways of visualizing the same question. Okay, so there's no excuse at all. Whether you think that you're good at math or not, using one of these 3 approaches, we should be able to get the answer. Okay, all right. That's number 5. Let's see if we can get to 6. Let me get 6 back here. Hang on. Let's get 6. Okay, Ford, read 6 for me, please.
Likely is to, probability as unknown is to.
Mm-hmm. And what are your options?
Measurement,
Mm-hmm.
geometry, number algebra.
Your answer would be?
Algebra?
Okay, why?
Because unknown is a part of algebra,
It's one of
and
those.
likely, yes, one of the main parts of algebra.
It's one of the key terms that is associated with the concept or the strand algebra. Okay. So when we think of measurement as a strand, we're thinking of meter, um, liter, and that, if we're looking at measurement like that. Geometry, we're thinking about shapes and all of that. Number, we're thinking about addition, subtraction, multiplication. We can think of it in terms of prime, composite, odd, even, all of those things. Okay. All right,
Yes,
cool.
sir. Unknown could be the variable.
Unknown is the variable. Okay. So that one answers that. Well done there. Let's go to number 7. Now, let's throw this one to YouTube. Let's go. Bob has a shoe store. What statistical term should he consider when buying shoes? What statistical term should he consider when buying shoes? Is it the mean, the mode, the multiple, or the median? I see somebody saying here the mean. All right. Somebody else here says mode. Somebody saying multiple. All right. This is, let me go back here. Where are we? This one, number 7. All right, mean. Let's hear. Why do you say mean? Andre says mean. Why mean? Drop it in the chat and tell me why mean. I'm going to take out, let's take out multiple. Let's multiple, and we're going to take multiple out. Okay. Median has to do with a middle number, so we could take that one out as well. So we're left with the mean, and another word for mean would be average. Okay. And mode in math, what does in especially in stats, what does mode, which one occurs the most? Okay, so let's see. Tuyin says mode, the one that occurs the most. All right, so why are we thinking about this one? All right, to find out how many shoes are in the store. Ford, what's your thinking on this? Tess, what's your thinking on this?
What did you say, sir?
What's your thinking on this question?
I would think the answer would be A, mean.
Why?
Yes, sir.
Why mean?
Because probably when he's buying shoes, he
Mm-hmm.
has to find the average amount he buys on a regular basis for the store, or it could be the average shoe size of the shoes he buys.
I see the average shoe size. All right.
Yes, sir, I agree.
All right. let me put this here. There's another question just like this, and we're going to come back to our answer being mode. Okay, we're going to come back to our answer being mode, and when we complete that question, we'll see why it's going to be the mode. Okay, what mode means again? The one that you see most often. Now,
Sir?
when you go into a shoe store, do you see size 14 shoes as a popular size? 14.
No, sir.
No,
Do you
sir.
see, do you see size 1 as a popular size?
No, sir.
No, sir.
Ah, so there is a size that will be popular, okay? And you will find several pairs of that, okay? If we were to find several pairs of that particular one, what would that be? Using the terms mean or mode, which one would
The
it be?
mode, sir.
Mode, because you see several pairs of it. But again, there's a question that is coming up that will help us to see this better than we're seeing it now. Let's continue with our stats though, and let's look at sum in question 8. Okay, question 8 says, Sam scores the following on 5 of his math tests. He scores a 95, an 80, 90, 90, and a 70. His score on the 6th math test was a 95. Me love how some are going Selena with the 95. Which of the following will not change? Is it the median, the multiple, the mean, or the mode? Which one we can just get rid of immediately? Tell me.
Multiple?
Good. We could take out the multiple because the multiple is not a statistical reference that we want to use here. Okay, so we can take this one out. Multiple. That's done. So we're thinking of median, what? Mean and mode. Okay. So in stats, what's the first thing that we need to do with our let's go. What's the first thing that we need to do? We have our data here, or numbers. What do we need to do? Anybody?
Arrange them in ascending or descending order.
Praise the Lord. Arrange them in ascending or descending order. So, which one would come first?
So if you were doing ascending, 70 would come first.
I would have 70 first. Hang on, let's get this so you can see. All right, let's put this side by side. Can you see this? All right, so 70. Then what?
80.
Good. Then
90,
The
sir.
the two
Both of
90s.
the 90s.
and then 90, and then 90, then
And then 95. And the
then
other 95.
95. Hold on, let's look at it first, because it says which of the following would not change, because we're going to deal with this before putting on the other 95 and then after, to see if there's a change in terms of the median, the mean, and the mode. So let's go with this first. What does median mean again?
The number in the middle, sir.
Number in the middle, or this maths teachers like to talk about central tendency. What's there in the middle? All right, let's go. How do I find this? How do I find what's in the middle?
Sir, you could probably make sure that on both sides of a number there's an equal number of
All right.
numbers.
So I like to just do this. 1 over here, so 1 over there, so 1 over here, so 1 over there, so. Well, if in the middle, 90. True? That can work? Can that work?
Yes, sir.
Cool.
Yes,
So
sir.
the median in this situation, in scenario 1, the median here is 90. Okay, cool. What's the mean?
Sir,
How would we find the mean now?
We would add all
By
the numbers and divide it
All
by
right.
5.
Can we do we have a mode?
Yes,
What's the mode?
90,
Cool. Mode is 90.
because it appears more than once.
Good. All right. So there. Let's go now, and we're going to do what? Add all of these. So we
yes,
have
sir.
70 and 80 and then 90 and 90 and then 95. Add all of these. This would be 5 on this side, and then 9 and 9 and 9. That would be what?
27.
27 and 8 would be what? 20,
35, sir.
35 and 7 would be what then?
42, sir.
42. So this becomes 425. This is the mean?
No,
No,
sir.
sir, we need to divide it by 5.
So we'd have
You
to
have to
divide.
divide it by how many is there.
So 1, 2, 3, 4, 5. Oh, so 425 divided by 5. Yeah, so 5 into 4, that can't work. So 5 into what? 5 into
42, sir.
42 goes what again?
8 times, sir.
Okay,
Remains
because
the 2.
8 times the 5 would give me what? 40. I would have
Hi.
what? 2. Bring down now. I have 5. Can 5 go into the 25?
Yes, sir, 5
Yes, sir.
times.
Okay, 5 fives would give me 25, and I'm all done. Cool. So the mean here would be 85. Cool. This is scenario number 1. In order to answer the question, I have to look at it. When he added what? The next 95. Okay, you seeing that? When he
Yes,
added
sir.
the 6th score, which was 95. So let's go 70, 80, 90, 90, 95, 95. Let's go again with scenario 2, the median, the mean, the mode. Let's go mode. Let's look at this. 1 over here, so 1 over here, so 1 over here, so 1 over here, so now I have 2. This scenario, I have an even set of numbers. 1, 2, 3, 4, 5, 6. How do I find the mean, the median rather, with an even set?
Sir, you would add both of the 90s, which would give
So,
you 180.
so this is 180. Then what?
Sir,
Divide
then
by
you divide
2.
it by 2.
Divided by 2 and I get 90. All right, hold on. So the median is 90. But look here, so this was 90 and this is 90. It didn't change.
No, sir.
Hold on. Let's go again. What will change now? Let's look for the mode.
The mean.
No, hold on. The mode changes.
No, sir.
The mode not change.
Yes, sir.
We have
Yes, sir. Yes,
90
sir.
and
Yes,
95.
sir. Yes, sir. I
Oh,
didn't realize there were two 95s.
okay, and 95. Now, if I had 425 here, what do I need to put onto this to get the new total on this side?
Sir, another 95.
Cool. So 425, and just put on a 95 on this. 5 and 5 would be 10. Write 0 and carry 1. Let's just say 9 and 1 would make 10. 10 and the 2 would make what? 12. Write 2 and carry 1. Now I have 520. What do I need to do with my 520?
Divide
by
it
what?
by 6.
By 6, because we have 6 numbers now. 520, let's divide by 6. 6 into 5 can't go, so we would say 6 into the 52. 6 into 52, how many times?
Sir,
6 1, 6, 6
8
2,
times.
6 8 would be 48. 6 9s would be what?
6 9s would be 54.
So
54,
that's
sir.
too much. So I have to take the 6 8. All right. And this would be 40, what you say, 48. Let's take away 48 from the 52. What do we have?
4.
4. All right, cool. So we have 4. I'm going to bring down this, and this would be what? 0. No, 6 into the...
So 6 times, sir.
6 is 36.
Okay, 36. Let's see, what do I have left? I have what? 4.
4
And
left,
then
sir.
what? And then? I'm not hearing you. What would I have to do afterwards?
So you have a remainder of 4. So you would
4.
have a decimal point.
All right, so we could add a decimal point here. Add some zeros to continue, bring this down. I have here 6 into this, and because this is 40, then this 6 will just continue on and on and on.
Are we recurring decimal?
Okay, cool. So the mean, is the mean the same?
No, sir.
The mean was 85.
No, sir, it was
And now the
85
mean will
before.
be 80 what? 86.6
6.6.
something, and it continues and continues. So let's go back. Which of the following will not change? Hold on, let's bring this so back so we can see this. Cool. So the question asked, which of the following will not change? Which one would not change?
The median, sir.
The median did not change. The mode changed from 90, just 1, to 90 and 95. The mean, hold on, let me bring back the picture here so that we can all see this. Let's go. Okay, so again, let's look at it. The mode changed because we had 90 and then we had 90 and 95. So that changed. The mean, we had 85 and now we have 86.6 and it continues. We only stopped there, so because of time, okay, at one place. But we recognize that the median was 90 before and the median is still 90. The question asked us for what? The one that would not change, okay? So now we know which one does not. All right, let's go to number 9. Let's go to number 9. Let's see what 9 says. And we're going to stop at 10, okay?
Yes, sir.
All right. Let's go with number 9. Number 9 says, which number best completes the sequence below? Let's give our friends on YouTube the chance to do that one. We have 100. We have 81. Then we have 64. Then we have 49. Let's go. People on YouTube, let's focus and see if we can get this one here. Let me pull this side by side so that we can have a look. Okay, I see. Let's go. I see Brown saying 36. Let's see. King saying 36. Abraham's 36. Sterling 36. Let's go. Ho. Here we go. 36 because it's squared numbers that we're dealing with. Let me see. And that was Bree. Bree, tell me how you know that we're dealing with square numbers there. Where we get that from?
Because 10 squared is 100.
Oh, so 10
9
squared here. 9 squared 81. And they're going down. It look like 10, 9.
9.
Then
8 would be the next one.
oh, 8 squared is 64. So
7.
oh yes, 7 squared. Then if this
Then the next one
go
would
down, then one after the so this must be 6 squared. And 6 squared would be what?
36.
36. Excellent work there. 36. Our last question for the evening. Let's go with this.
Sir, there's also another way.
Oh, tell me, please. Just before we go, love to hear
Yes,
the
sir.
other way.
I realize that they're subtracting by odd numbers going down below 20. So
Mm-hmm.
100 subtract 19 will give you
Mm-hmm.
81.
Mm-hmm.
And then 81 subtract 17 will give you 64.
Okay.
And 64 subtract 15 will give you 49. And then
Mm-hmm.
the other odd number would be 13. So 49 subtract 13 will give you 36.
All right, cool. That can work as well, but the one that I want you to focus on is the situation here with the what? The squared numbers. So we also need to know that 10 squared is the same as 100, 9 squared would be equal to 81, 8 squared would be equal to 64, 7 squared would be equal to 69, and 6 squared would be equal to 36. Now, am I saying that the way that you're looking at it does not work? There are multiple relationships. One of the things that we recognize in ability is that sometimes there are many relationships that exist. Some relationships are more obvious than others. This one is very obvious. Okay, the other one is also another way of expressing that relationship as well. Okay, but please remember this one. All right. Okay, last one, number 10, last one for this evening. Let's go with number 10. Let's put this back so you can all see it. True or false? These easy. Let's go with this. YouTube people, this one's yours. All odd numbers end with either 1, 3, 5, 7, or 9. True or false? True, false? So let's go. Harris says true. Okay. Harris says true. Friday says true. Abraham's true. True, true, true. True there, Heman. Alton true. Chiara true. All right, cool. So we'll take that. Okay. So odd numbers end with or in the ones place, we'll find 1, 3, 5, 7, or 9. Next one, people on YouTube. Outcomes are always fair. What say you? Are things always fair? If we're testing something, making certain observations. Okay, false for that one. False, false. Okay. Did you know that sometimes when you have quote unquote dice, you have to we have to make a qualification that you have what? Fair dice. Some of them may be weighted in a particular way that it will always land toward a certain set or number, and a certain number or set of numbers because of how they construct it. So when they're playing certain games, you have to ask for a pair of fair die. Okay, fair dice. So outcomes are not always fair. Okay, that's not always the case. Last one, graphs are only used in mathematics class. True or false? Tess, what say you?
Sir, I would say false.
Tell me one other subject that you have seen graphs in.
Social studies, sir.
Tell me where in social studies you see this graph business.
Sir, to show the most popular negative effects on mountains.
Okay. Um, let's see if we can see this. Let me pull this one up for you here. Uh, This is our social book, And here we have graph looking at the what? Millions of square kilometers for the Pacific Ocean. And just looking at this, we know that the Pacific Ocean would be what? The largest ocean, then the Atlantic, then the Indian, then the Southern, then the what? Arctic, just based on this. This is not math. This is what? Social studies. I see Heyman. Heyman has a very good point here. Let's go. Heyman, rainfall in social studies. Hang on a second. Rainfall, you say in social studies? Wait. Can I find rainfall here? Well, I'm not finding rainfall. I think this one, remember this one? We're dealing with, what was this? Temperature? No? Rainfall. She's right. So here we had Kingston and we had Port Antonio, and we were looking now to see which one of them had what? More rainfall, and we were trying to find out why. Okay? So we know that overall, Kingston has what? Lower what? Rainfall than would Port Antonio. And just a little social here, that's because Portland would be on the windward side. Okay, so it's going to be very wet here. And by the time the rain climbs over these mountains, those moist clouds, and dump the rain out, the other sides would be pretty dry. All right, so that's that. So again, for math is not the only place that we're going to use graphs. All right, guys, it has been a long session. Thank you very much for joining. I hope that our explanations have helped you and that you will be better able to answer some of these questions when they come along. All right, take care. This is where we will end our live stream. Again, keep preparing. It's never too late for a shower of rain. Okay? Bye, guys. Oh, yeah. Your PEP questions. Here we go. Let me copy this and drop this in the chat. I got some questions from you the other day. Let's keep adding them. I'm going to drop it in the description box as well. And you can use that link to send in your PEP questions that you have created. We'll put them into a quiz, and then we will all see who is the what champion of champions for that particular quiz. All right, people, get your rest. See you guys in our next episode.